Sketch a curve with the given vector equation and indicate with an arrow the direction in which t increases. Our equation is the vector function r of t is equal to 2 times the cosine of ti plus 2 times the sine of tj plus k. In trying to understand a curve, sometimes it's useful to come up with parametric equations, and so I'm going to do that. X is equal to 2 times the cosine of t, y is equal to 2 times the sine of t, and z is equal to 1. We notice a couple of things. Well, I hope we do. One of them is that x equals 2 cosine t and y equals 2 sine t represents a circle of radius 2 centered at the origin. Now, I've written down circle with radius 2. I'm not going to write down center at the origin because here our center has been moved up 1 unit in the z direction. And so by bringing in the fact that z is equal to 1, we can say that the center is at 0, 0, 1. So we have this circle of radius 2 floating above the xy plane. Let's see if we can represent that graphically. All right, let's see what we can do here. Am I okay with that? Not so much. I'm going to try to get it with just one stroke here. There it is. Cool. Folks, with the tools that I'm using, I can have this give me a nice circle and then start tweaking it and make it look real good in perspective. But I want to show you what you'll likely be doing on your own paper. Now, having done that, I'm going to use these tools to represent where I see this living in space. So what I'm going to do is I'm going to create basically a shadow of it in the xy plane. So there's its trace in the xy plane, and we can see that I'm representing this to have a center that has been moved up 1 unit. And then I'm going to make this tick mark on the z-axis, if I can, parallel to the x-axis. And then here I'm going to mark the x-axis as a 2 where the circle intersects, and the y-axis is 2. And I'll just go ahead and do the negatives as well. You don't have to do all that. But there we can see I'm representing now a circle of radius 2 with the center on the z-axis 1 unit up. Now we've almost done everything that was asked, but we are to indicate with an arrow the direction in which t increases. For this, what I'm going to do is I'm going to put in some just a couple of values of t. I only need 2 to figure out the direction. I'm going to look at r of 0 and then r of pi over 2. And r of 0 is going to give us 2, 0, 1. And it's the vector 2, 0, 1. R of pi over 2 is going to give us 0, 2, 1. So r of 1 lies above the x-axis. Excuse me, r of 0 lies above the x-axis. R of pi over 2 lies above the y-axis. And so we can see that the circle is moving in the counterclockwise direction if you're viewing it from above. Next example, same instructions. The new function here is r of t is equal to the sine of pi t, the cosine of pi t. This has a kind of similarity to the previous exercise in which we have, in that we have a sine and a cosine. But now the sine and cosine are related to the x and z coordinates, right? So what we actually have now is a circle with a radius of 1. But this circle is in the xz plane. And rather than having a fixed coordinate for the y coordinate, or for the j component, we have t. And so this circle is going to get traced out, and y is going to take on various values. Now I'm going to erase what I'm about to draw in a minute, but when we say that there's a circle in the xz plane, and really what I mean is a trace is a circle in the xz plane, that's our circle, but we have a situation in which we trace out, we take on different values of y. So basically, we need to take this circle, but stretch it out. And we're going to end up with a helix, or something that looks like a spring. Now I don't want to just randomly put a spring here along the y-axis because I need to know where it crosses the xz plane. So let's explore that. Where does it cross the xz plane? And when that happens, of course, y is equal to 0. So we're looking at r of 0, which is going to be 0, 0, negative 1. No, it's not. It's 0, 0, 1. I saw pi t. I got all up in the pi business here and thought that cosine of pi is negative 1. Forgot that pi times 0 is 0. Anyway, we're looking at the point 0, 0, 1. So I'm just going to put that point on the z-axis there. And right now, I'm going to do another one because it would help if I had a direction right away. So I'm going to use r of 1/2 because we already have pi's in here. So putting pi over 2 there would just make it weird. And the sine of pi over 2 is 1. And then t is going to be 1/2 for the j component. And the cosine of pi over 2 is 0. And since z is 0, this is telling me where it's going to cross the xy plane. And we're looking at 1 and then 1/2, 0. So now I have this idea of a circle that is being stretched out, so a spiral. It's going to start on the positive z-axis. That's where it hits the xy plane. And then to draw that it's a spiral, I'm just drawing a few loops there. And I'm going to quit while I'm ahead on that one. But I do know that it should, oh, and here's the arrow, right? That because we went from the point on the z-axis to the point in the xy plane. And I'm going to go ahead and continue this along the negative y-axis. Wish me luck on this one. This is always a challenge here. And I think that's, yeah, I'm going to call that good enough. Cool. There we are.